Okay, so for the last segment of this, and of course, exam review, we're doing 31 to 45. 30 is asking us for the maximum value of the function. Maximum value of the function is really your k value. So you're trying to find k. There's a couple different ways to do it. I'm going to do first what we just did in the conic section, which is we completed the square to find k. So remember that if I have this, I have a coefficient on my x squared term. So I'm going to factor that out of my x squared and my x term. So if I take out -2, I'm left with positive x squared plus 4x. And I'm going to complete the square in here. And I'm leaving the -10 there. Remember to complete the square with a quadratic. I add inside the parentheses and I subtract outside. Because I factored out this -2, I have to also multiply whatever I use to complete the square by that -2 as well. So again, that -2 has to repeat there. And again, I have 1 plus 1 minus. So remember that the value that we use to complete the square, we talked about that the factored form is always going to be this number divided by 2. So that's going to be x plus 2. And then to get the number that goes in the blank, we square that number. So 2 squared is 4. So we're going to place 4 within the blanks. So we have f of x is equal to -2 times x plus 2 squared. So we're only concerned about k. Right now we know what h is. And then -10, and then that's going to turn into plus, because I have minus a negative, and then 2 times 4 is 8. Okay, so instead of -10, so I have -10 plus 8, which means f of x is equal to -2 times x plus 2 squared minus 2. So this value is my k, so my maximum value is equal to -2. Another way that you could do that is h, remember, is always equal to -b over 2a. And then whatever that is, plug that value into f of x. So meaning you're going to do f of h equals y, equals k. Okay, so that's a different way to find the value for k. It's an extra formula. So since this was recent, it's probably better for you to just practice using completing the square. So number 32 is something that we didn't go over this year. And so again, this is part of the accounting for like the extra credit points. So when I'm multiplying two complex numbers together, remember that I squared is equal to -1. So I'm going to FOIL this out, or if you prefer to use the box method, you would use that area model. So I've got -2 times +4 gives me -8. And then -2 times +7i is -14i. -3i times 4 is -12i. And then finally, we've got -3i times +7i, so -21i squared. And so we're combining like terms. And so in this case, we just have a -8 right now. And then -14i plus -12i gives us -26i. Remember that I squared is actually just -1. And so if I have -21 times -1, I really have +21. And so then that means that we have, if I combine the -8 with the 21, I've got, it's not negative, +13 minus 26i as the product. Okay, so not necessarily a hard concept, but just something that we didn't go over for this year. Okay, so 32 was that. 33 is also complex numbers. So remember that complex numbers come in the form a plus bi. The conjugate of that is a minus bi. Okay, so whatever a is, so in this case, a is -6 and b is +8. All we do is change the sign on b. So the conjugate of this then is -6 minus 8i. So again, something easy if you remember that vocab. But since we didn't go over it, it's accounting for one of those 5 points that I'm giving you on the test. Okay, so number 34, we're asked to be part of a team that you've been asked to be part of a team to gather data on 3 upcoming studies. Your task is to decide whether the method of data collection is most appropriate. So experiment. So remember, with an experiment, it's something where you have 2 groups and you usually use some kind of control and, wow, I can't spell control. And then someone that you give a medicine to. A survey, I think, is self-explanatory. So survey, you're asking questions. An observational study, you're just watching. So you aren't actually asking any questions. You're just looking at something. And so team captain wants to know what his teammates eat before a match. That would be best found using a survey. So just by asking them is the best way to figure out what they ate. How praising teammates affect the teammates' performance. So if you're looking at how praising affects them, it would be best to use an experiment. So to praise some of them and to not praise others. And kind of compare those 2 groups. And so then we should be able to get, this one should be an observational study, and let's see if that makes sense. So if they want to know who can score the most goals against the best player. So if you were just watching who scores the most goals, right? That's an observational study. Okay, so for 35, we have a pile of earth removed from an excavation site is a cone measuring 11 feet high and 6 feet across from its base. So let's kind of sketch out a cone. So we've got a cone. 11 feet is the height. And then if it's 6 feet across, that means that's the diameter. And so we're really looking for, that means that the radius is 3 feet, because we know that radius is part of most of these formulas. So it's asking how many trips will it take to haul away the earth using a dump truck with a capacity of 20 cubic feet. And so what we have to do is we have to find the volume of the cone divided by the capacity of the truck. And so remember, if you look back at the formula sheet, the formula for volume of the cone is 1/3 pi times r squared times h. And then we're going to divide that by this 20 cubic feet. If I can get it. There we go. We're going to divide that by 20. So the height is 11 feet. The radius is 3 feet. So we're doing pi divided by 3 times 9 times 11. So I'm going to just start with, if we simplify this, this is 33 pi, and we're still going to divide that by 20. So if I estimate 33 pi, that's about 103.7 cubic feet, and then we're dividing that by 20 cubic feet. And so that gives us about 5.18. And so this means that it will take 6 trips. So remember that for this, we always round up. We don't like say, oh, it's only 5 because it's less than 0.5. This is always rounding up. So for number 36, we're given the equation for volume of a cylinder, it looks like, and they want us to solve it for R. So we're looking at kind of the literal equations that we did at the very beginning of the year, where I'm just rearranging a formula. So if I know the volume of something and I want to find the radius, I would use this formula instead to find that. And so since everything here is being multiplied and I want R by itself, I'm going to divide by everything, and then I can at least get R squared by itself. So I've got volume equals pi times R squared times H. So if I want to get rid of pi and the H to the other side, I'm going to divide by pi times H. So that means that now I have R squared equals the volume over pi times H. And so then to get rid of the R, I would take the square root of both sides. So that means that the radius is equal to the square root of V over pi H. I know that normally when we do this square root, we write plus or minus, but because this is measurement, they're always positive. So I don't need to account for, yes, R could be a negative value and I would still get the same volume, because R realistically, conceptually can't be a negative value. So for this one, we don't have a plus or minus like we did in the inverse problem that we did on the first page. Number 37 is average rate of change. I'm going to scroll down to the equations really fast. So average rate of change is here. So we have to find f of b minus f of a over b minus a. Okay, so it's asking us for that. Remember, this is just fancy for kind of slope of the line. So we're finding f of b. So b here is 5 minus f of a is 2 over 5 minus 2. Okay. So let's calculate out f of 5 and f of 2. So f of 5 is going to be 5 times 5 squared minus 2 times 5 plus 2. So 5 times 25 is going to give us 125 minus 10 plus 2 gives us 117. So f of 5 right here is 117. And then if we plug in 2 to the equation for f, is 5 times 2 squared minus 2 times 2 plus 2. So 2 squared is 4. 5 times 4 is 20. So 20 minus 4 plus 2 is going to give us 18. And then I'm just going to simplify. 5 minus 2 we know is 3. So 117 minus 18 is going to give us 99. 99 divided by 3 is 33. So the average rate of change for f of x on the interval 5 is 33. Okay, on to the last page. Fraction exponents, remember the idea here is that if I have x to the a over b power, that's equal to the b root of x raised to the a power. And so what I want to kind of look at is, so 27 is my x, essentially. A is 2, b is 3. So if I put 27 inside the radical, the 3 is going to go in front. So I'm going to have the cube root of 27 squared. Okay, so I'm taking the cube root of 27 squared. The cube root of 27 is 3. And then 3 squared is 9. Okay, so simplifying without fractional exponents gives us 9 for this problem. For number 9, we have an exponential function. The big idea here for an exponential function is to try to write them with the same base. So we have 32 to a power equals 2 to a power. We want to try to write them as the smaller number. If we can't, we would try to write them both as other numbers. So 32 is actually 2 to the 5th power. Okay, so what we want to rewrite this 32 as is 2 to the 5th, and then we have our x plus 3 as a power equals 2 to the 4x. And so what this means is when I have a power raised to a power, remember our rules tell us to multiply those values. So what this really is 2 to the 5x plus 15 equals 2 to the 4x. And so now that our bases are the same, in order for these two things to be the same, my powers would also have to be the same. So I'm essentially ignoring the 2's now and setting up an equation using the just my exponents. Okay, so I've got 5x plus 15 equals 4x. I need to stop changing colors because I think my battery's dying over here. Okay, so 5x plus 15 equals 4x. And so I'm going to subtract 5x from both sides. So 15 equals negative x. So then if I divide by negative, x equals negative 15. Okay, so then for numbers 40 and 41, we're using this distribution of pizza delivery times. And so the first question, 40, is just asking us essentially if we know what different things mean within the graph. And so the mean of a normal distribution curve is always the middle number. So the mean of this is 30 minutes. Standard deviation, remember, is the spread. So it's how spread out the values are. So standard deviation for this is how much I have to add or subtract to go either direction. And that's 5. So I'm adding 5 or I'm subtracting 5, depending on where I'm going. So my standard deviation is 5 units, okay, minutes. Number 41 is asking us what percentage of pizza delivery times fall between 20 and 35 minutes. So it's asking us what percentage represents this part of the graph. So going from this line to the line for 20. And so this is using the empirical rule. Remember that the empirical rule is also called the 68, 95, 99.7 rule. So that means that this chunk of the graph is 68% of the data. Remember what we looked at is if this line was here, that would mean that these were each 34%. The next standard deviation out, so if I go out one more both directions, that's 95% of the data. And so that to get the what each of these smaller bars were, we did the 68 minus 95, or sorry, 95 minus 68, which is 27. And then if we divide that by 2, that means that these are each 13.5. And then we talked about what's left here is we didn't ever do from 15. So that means that the rest of this is 2.5%. This side's 2.5%. And so all that we would need is to add up the values that correspond to the sections that we're looking at. So from the 20 to the 35, we're adding up 13.5 plus 34 plus 34, which gives us about 81.5%. Okay, so 42. Annie invests $5,550 at 3.5% interest, compounded continuously. That means we're using this formula over here. How much money will he have after 10 years? So the amount is how much money he will have. P is the principal. So P is how much he invests. So A is going to be equal to, whoops, that's a 5,550. E is, remember, a button on our calculator. The rate is the interest rate. How we have to write it as a decimal. And so in this case, R is going to be equal to 0.035. And then time is in years. So times 10. So we're just straight calculating this into our calculator. So 5,500. And then you should be using, it's usually on top of the ln button. If you hit Shift ln, it'll give you E. So 0.035 times 10 is about $7,875.82. So this is really pretty easy. You're just plugging it straight into the formula. Just to remember that you have to change the rate to a decimal. For 43, we're solving exponential function. So this one's different than the one that we did in 39, because 39 we had two things with exponent. This one we just have one. And so what we want to do first is get the E by itself. So we're going to isolate the value for E. So we want this to be by itself first. All we have to do in that case is subtract 10 from both sides. So E to the 2x minus 5 power is equal to 6. Remember that ln of x equals y is equivalent to E to the y equals x. So what we want to do is switch this to ln form. So we're going to do ln of 6 equals 2x minus 5. And then remember that ln of 6 is something that we can calculate. So on our getter, we're going to type ln 6, and I'm going to estimate that to a couple decimal points just so that we have values. So that's about 1.79. And that equals 2x minus 5. And so now we just have to add 5 to both sides and then divide by 2, and that will give us the value for x. So if we add 5, that gives us 6.79 equals 2x. And then if we divide by 2, x is about 3.4. Okay, we got 2 more. Okay, so 44, a brand of light bulbs has a mean lifetime of 2,100 hours and a standard deviation of 120 hours. A sample of 400 batteries gave a mean lifetime of 1,600 hours. What is the margin of error for the sample? So the margin of error formula is given to you on your formula sheet. Margin of error is 2 times the standard deviation divided by the square root of n. So we're going to take 2 times standard deviation is 120. And we're going to divide that by the square root of 400. So 2 times 120 is going to give us 240. And then the square root of 400 is 20. So 240 divided by, that is going to give us 12. So the margin of error is 12 for this sample. So for these situations in number 45, we're determining whether they're uniform. So uniform is something where you have the same outcome for everything. This is usually like dice, spinners, that kind of thing. So some kind of probability situation. Normal distribution, remember, is something that usually comes from nature. Skewed right means that there are less on the right, and skewed left means that there are less data on the left. So if the test is easy, if this is a 0 and this is 100, you would expect to have more high scores. So this is the skew left because there are less scores on the left. If I'm selecting a color on a spinner, that's going to be uniform. And then if I'm looking at the weight of an adult in a large crowd of people, that's something that is coming from nature. So that's going to be a normal distribution.